Hi everyone, welcome to another Galaxy tutorial for bioinformatics session. In today's video, we are going to look at how to map RNA Seq Reads to a reference sequence or reference genome. So we are going to follow this tutorial here. I will leave the link to this page in the description box. And by the way, I've already covered this tutorial using the command line version of the tools. And so if you are interested in that tutorial, you can check the description box for that video. The link is there. So for this tutorial, we are going to use the Galaxy platform to do the mapping. So all that you need is an internet connection and an internet browser. So that's it. So when you are on this page, just scroll down. And if you're a beginner, I will encourage you to read the introduction here to help you get started. But I'll move straight to this section here. So we will first have to import our data. And so I'll come to this side, data upload. So I'll click it and I'll be sent to this section which has the links to the files. For this, we are going to use a single sample. So I'll use just these ones. R1, R2. We are dealing with paired and so I'll just use these ones. So I'll copy the links. All right, I'll copy them and then move to my Galaxy platform. So when you are here, and by the way, the link to this platform is in the description box. So when you are here, come to this side and then click on create new history. And you should also make sure that you have logged into your account. So click on new history here by using the plus sign here. And then when you click it, you have this unnamed history. So when you are here, edit it and then name it as mapping. Like this. And then save the changes. We just want to keep track of our activity. So after doing that, then what you can do is to come to this side here, upload data. So click it, and then after clicking, you have this coming up. So come to paste/fetch data, click it, and then when you are here, paste the links. All right, for the files, the two files, read 1, read 2, and then click on start. Okay, so after clicking the start, you should see this progress bar coming up. And if it's 100%, check this side and make sure that you have 2 output files appearing here. So once they do, you can close this one. And then you can wait for the files to be uploaded. All right, so this is how we import the files. Please take note that importing the files can take some time. All right, so if it's taking longer than you expect, you can just go do your other stuffs and come and check later. Or you can also use the galaxy.eu platform. I think I had that open somewhere here. Let me just check here. Yeah, so this is it. This is the Galaxy.eu. So there's the link. I'll also leave this link in the description box. So you can also try this one and then see which one runs faster. And then you can use that for the rest of the activities. So just check both options and decide the one you want. But I would advise that you also create an account for both and then just use the one you want. Okay, so now let's wait for the files to be imported. Okay, so the files have been uploaded successfully. So we see them here. Now let's take a look at the next activity. So let's get back to the Galaxy tutorial page. Yeah, so on the page, after importing, let's check. We are supposed to also check that the data type is FastQC Sanger and not FastQ. I repeat, the second activity is to check that the data type is FastQC Sanger and not FastQ. So let's get back to our platform here and then just check. So to check the data type, just click it. So I'll use this one first, the 2, and I'll check. So the format is FastQC Sanger, which is what we want. Let's check for the other one, which is this one here. It says FastQC Sanger. All right, so we also have that also done for us. So this is what we have to see. All right, so that is fine. So now we are good to go. Let's take a look at the next activity. So the next activity is to create a paired collection. But I will skip this activity because I have just one sample here. All right, so there's no need for me to create a paired collection. If you had multiple samples, then fine. But since it's a single sample, I will not do that. But we will still proceed with the activities. All right, so this is the only thing I'm going to skip here. But if you have multiple samples, then it's advisable to create your paired collection because that will make things easier for you. If you have any challenge with that, you can also let me know. What we will rather do is to rename our data set so that we add this information to. So we have, for example, GSM 461177 on treat paired 1 and then on treat paired 2. Okay, so that's what we are going to. So we are only going to add this to our file names. That's what we are going to do. So just make sure to do that as well. So let's get back to our Galaxy platform here and then rename the data. So if you want to rename a data, or let's say a file, anyhow you want to put it, to rename, just come to this side here. Then where you see this pencil here, click it. And when you click it, you have edit attributes. All right, so the edit attribute allows you to edit some things, some information about the data or file. So here we'll rename. So here we have GSM, so and so. So I'll just add that additional information to it so that we have it renamed. Okay, so that's what I'm going to do next. But also you can decide not to rename. All right, it's not really important. The most important thing is to be able to track your data, okay, and then the outputs. That's what you need to know. So you should always take note of the numbers that are assigned to your output files or the inputs files so that you can map them out to the other outputs. So that's what you need to do. But I'll just rename it so that it's uniform. So I'll just put that here. So this is 2, that's read 2, reverse. So we need to also factor that in. So I'll just paste the information there like this. And I'll say underscore. It's supposed to be this. So we have GSM, this, the underscore here should be 1. All right, so this is what we should have. So GSM 46117 underscore on treat underscore paired underscore 2. This is what we should have. But anyway, I'll put these names in the description box. So in case you have any challenge, just go and copy that and then just paste it there. All right, so and paste everything there like this. All right, so I'll do that for you. So that's it. So this is for read 2. So I'll save it. And I'll also do same for read 1, which is this one here. All right, so that's what you need to know. Okay, so let's proceed. So I'll just edit it and then I'll add that also here. Let me paste that info here. Okay, so that is also done. So we can save the changes. Okay, that's fine. So I repeat, because it's just a single sample, I don't need to create a paired collection and use that. I'll just proceed with this one here. Okay, so these are the new names. So we can proceed. So what we are going to do next is to run FastQC. Anyway, let's just proceed. Let's do something first. So let's do this. Let's come to this side. Galaxy, let's just click it to go to the home page again. And then let's take a look at the next activity. So I'll come to this side and then I'll proceed. So you should also take a look at the question here. I was scared, by the way, but if you're a beginner especially, take a look at the questions here and the solution. That will help you to better understand the file formats. So that's what you need to know. Now let's move to quality control. So Quality control helps us to identify potential issues, and these issues can be resolved, and resolving them allows us to remove low quality reads. So this will ultimately save us time when we are analyzing the data. So you should always perform quality control on your data. So for the quality control, there is an entire tutorial on it, also made by the Galaxy team. So if you're interested, you can just use this link. I think it's this one. Let me just see. Yeah, so this tutorial is one of them. Let's check. Yeah, so this tutorial is one of them. Let's just check and see. Yeah, so that's it. So I'll leave the link to this page in the description so that you can also use that to learn more when it comes to quality control. So just make sure to check it. All right, so let's do that. So when you come to this side, I will skip the first step because we did not create the collection, the paired collection. So I will skip this one and move straight to this one. So we will use FastQC. We will run FastQC on our data. And then after running it, we will look at the output, the reports, and then we will aggregate using multiqc. So that will be the first thing we will do. So let's first run FastQC on our data. So I'll come to this side. Let's check the platform first. Yeah. So I'll come to the platform. I'm already here. Let's just check. Yeah. So let's move to the Galaxy platform and then perform the QC. So I'll call FastQC. So I'll just search as here, FastQC, and then I'll click it. Okay, so we have opened FastQC. So when you open it, you will see this. Now, if you take a look at what has been displayed here, it's just a single file, one of the files. But what we want to do is to run FastQC on all the files. We have two of them. So when you are here, use the second option here. So when you hover your mouse on it, you see multiple datasets. So click it, and when you click it, you will see the two files appearing here. If you have more than two files, all of them will appear here, but we are dealing with two, so we will see them here. So when you see them like this, we have to select all of them. So to select, you can click on one of them and then press the control button on your keyboard and then select the other one. So this will select both files for you. So that's the only thing that we need to do here. Let's check if there's something else we need to do in the FastQC session. All right, so I think it's just for us to only select the files, and we have done that. So let me just go over again that this side, this step one here, I've omitted because I did not create the paired collection. So that's why I just moved straight to selecting the files like this. All right, so that's what you need to know. So once you have selected them, you can run FastQC. So click on run to. So this button, you can find it here, and you can also find it here, but I'll use this one here. So I'll click it to run FastQC. So let's wait for everything to get done for us. We are going to have 4 outputs after it's done. Okay, FastQC has completed its work. So we will see our outputs here. So we have 4 outputs. So we have a web page and a raw data for each of the files. So what I want you to also take note is the numbers. So for each of the files or each of the outputs, you have numbers assigned. So we have 1, 2, up to 6. So with the FastQC outputs, you will see this one, for example, number 3 says FastQC on data 1 web page. So that means it's a report for data 1, which is here. So you should always take note of the number so that you can use that to select the corresponding or to map the outputs to their respective inputs or files. All right, so what we are going to do is to examine the web pages, and then we are going to use that to answer this question here. So we will inspect and then answer this question. It says, what is the read length? The solution is here, by the way, but we will check it out once we have examined the web page. So we have 2 web pages, this and this. I will download them myself and open with my browser. So you should also do same. So I'll start with 3. Okay. Now the number 3 here is for data 1. Data 1 is the read 1. So if I'm downloading, I'll click and come to this side and click on download. And when I'm here, I will say read 1 underscore. All right. So that I know that it's for read 1 and I'll save it. I'll also do same for read 2. I repeat, I'll do same for read 2. So here I download, I come to read 2 like this, and I'll save it. So now I'll go and then check the files. So these are the files. So I'll open read 1 and I'll see the HTML files. So I'll just do this. I'll select this one here. And I'll also do same for read 2. I'll select it here. So these are the two files. So I'll open both with my browser. This is for read 1. This is for read 2. All right, so let's just look at them. So we can just come to this side. Let me just show you. Yeah, so the question is, what is the read length? So we can see that here, sequence length 37. And we also see it's also here the same. So I just thought I'll bring this to your attention. All right. Now for FastQC output explanation, I've done some tutorials on that. So I'll leave the links to those videos in the description. So that will help you to interpret your outputs or the reports. Alternatively, you can also check this tutorial here. It's also a better tutorial for quality control. You can learn more when it comes to FastQC. So the link to this page is also in the description box. So that's what you need to know. So let's get back to our tutorial page. So with FastQC, it analyzes the files, okay, one by one. And so if you have multiple files, then it becomes very cumbersome trying to open each of the files and then looking at the reports. So this is where multiqc comes in. So multiqc will help you to aggregate your FastQC reports into a single document that you can view. And then when you view that document, you can select whichever samples of files you want and then just check them out. So we will use FastQC to aggregate the reports. So we have the options here, but let's first open it here. So I will open mine. So I'll say multiqc and then I'll select it. And then after selecting, I'll do this. Let me first okay, to just send them back. All right. So I have my multiqc opened. All right, this is my multiqc section. So we have to select our FastQC reports. So first of all, let's look at this question. It says, which tool was used to generate the logs? All right, so here it's BAM tools, but we use FastQC. So you have to click and then select FastQC. So you can scroll down to it, or you can also type FastQC here to show it. And then you can select it. So any of them should work fine. And then you can come and select your FastQC output. So click on Insert FastQC. And then you select the ones that you want. So when you come here, it says multiple data set. That's what you want. Okay, so just make sure you've clicked it. And you can select your two outputs. So we are using the raw data, which is this one here. And then this is the other one. So these are the files that we need. We don't need the HTML, so we will skip it. So these are the files we need. So once you have done that, come to this side and click Run To. So when you do that, multiqc will aggregate the reports and give them to you. So let's wait for everything to get done for us. All right, multiqc has completed its work, so we will see it here. All right, so let's go back to the Galaxy tutorial page here and just check. So we have some questions here we will use to answer. We will use our output to answer. Of course, the solutions are here, but we'll compare and then see what we have. So let's download the multiqc report. So again, we will use the web page. You can also download this one, but I'll use the web page. So I'll click it, then I'll download it. Now this is just a single file. Okay, so because it has combined all of them, so I wouldn't give it a special label per se. All right, and it's also because I'm dealing with just a single sample, so I'll just use the default name. So I'll go ahead and check it out. So this is the multiqc report. So I'll open it and extract the web page here. And then I'll open it. So I have it open now. All right, so we have our multiqc. So you can also see our two files. All right, so read 1 and then read 2. You can see them here. You can see some statistics here. We can also see some plots here. So let's just take a look at this one. I'll focus on just this one. So we have the main quality scores for both files. So that's why we have two lines, one for read 1, one for read 2. So with what we have here, we see that the quality of the bases are in this region, this green region here. So the green region here are high scores. Those are bases with high first scores. So because we see all of them there, it tells us that overall the quality of the data is good because the bases have high first scores. That's what we see here. So that's what I'll say about the quality with respect to this one here. All right. Now let's take a look at the discussion on the Galaxy tutorial page here. So it says, what do you think of the quality of the sequences and what should we do? So the quality of the sequence, everything seems good with what we have. Now here we have two samples being made mention of, but we are using just this one. So I wouldn't talk about this one. All right. So for this one here, everything seems very, very good. That's what you've seen with this one. Let's check with the reports here, and it will run through the other statistics as well. So everything looks good, but it says all files except this sample. Okay, but this sample we didn't do it, so we didn't analyze it, so I will skip that information. But we will look at question number 2. It says, what should we do? It says all files except this one have high proportion of duplicated reads, except which is expected in RNA Seq data. All right. So this brings me to another thing which I have to make mention. So it says that the files have high proportion of duplicated reads, and because we are dealing with RNA Seq data, this is to be expected. All right. So we can see that even here. Let's check here. So we can see them here. So the black color represents duplicated reads, and we have them. So here for the R1, it's what? 45.3%, almost half. And then for read 2, it's 32.5%. So I mean they are high proportions of duplicated reads or duplicate reads. So that's what it makes mention of here, that this is to be expected for RNA Seq reads. All right. So if you see that in your RNA Seq data, that's normal. So that is for this observation. Okay, it's still for question 1, by the way. I should have made mention of that. So that's still for question 1. So we also have some statistics here that you can also check, and we have discussions here. So I mean, in general, everything looks good. All right, everything looks good to me. But the only exception was for this other sample, which we didn't do. So I think I'll skip that for now, because that's not the focus of our work. But I will encourage you to check the other discussions here and then read more. So let's take a look at the question 2. What should we do? I think that one is here. Let's just check. It says, if the quality of the reads is poor, we should check what is wrong and think about possible reasons for the poor read quality. So for the poor read quality, it may come from type of sequencing or what we sequence. Maybe high quantity of overrepresented sequences in transcriptome data, bias percentage. I mean, so sometimes you may have issues, but these issues may be inherent. They may be a property of the sequencing. Okay. For example, if you are dealing with long reads data, for long reads, since they are prone, you may see some of these stuff. And you can also have some anomalies. For example, if you are dealing with whole exome sequencing, then the GC content may be affected. The plot for GC, let's just take a look at that. I think I saw it somewhere here. yeah, it may be affected because for whole exome sequencing data, you have a non-normal distribution, but which is to be expected for whole exome. So I mean, some of the stuff, some of the errors you may encounter may be due to sequencing, and some could be other reasons. And of course, that's why we are discussing this. And also, if you have issues, then you have to contact the sequencing facility and let them know. I repeat, if there are issues, you can contact the sequencing facility also to let them know, maybe contamination or maybe protocols, and they can also check and then see the possible reasons. And then sometimes you can also resolve them. For example, if you see some reads of low quality, you can remove them, and you can also do some trimming, okay, to remove the ends of the reads. So these are things that we can also do. So again, I will encourage you to check the quality control tutorial to learn more about quality control. So that's what we are going to do. So we will proceed. So what should we do? It tells us we should trim the reads to get rid of bases that were sequenced with high uncertainty. So these are low quality bases. So we are going to also do that. And so that means that we are going to trim the ends. So that's what we are going to do. And also we are going to remove reads of overall bad quality. So there are two things we are going to do here. We are going to trim, and we are also going to filter or drop reads. So trimming and then filtering of read, that's what we are going to do next. It's also part of the quality control. So why do we trim? For paired end Illumina reads, most of the time, let me just check here. Most of the time, the quality of the reads drop towards the 3' end. And so if you perform QC on Illumina short reads, yeah, you may see that you have the quality and it drops towards the 3' end, which is normal. So what we can do is to trim the ends of those reads. So that is what we are going to do, and that's what this tutorial here is referring to here. And then we're also going to remove reads that are bad in all. Some reads overall, they are bad quality. Okay, the quality is low, so we remove those reads also totally from our data. So that's what we are going to do next. Okay, so for this question, we will not answer, or we will not tackle it because we just have just one of the samples. The focus of this tutorial is to map the reads using STAR. So I will skip this information, but you can try it yourself and let me know the outcome. All right, so we are going to do the trimming here. So we are going to use Cutadapt. So we will do trimming, and then we're also going to do some filtering. All right, so that's what we are going to do here. So we will run Cutadapt. So let's get back to our Galaxy tutorial. Yeah, not the tutorial page. Let's get back to our Galaxy analysis platform and then proceed. So that's what we are going to do next. So what we are going to do next is to run Cutadapt. So come to this side and then search for Cutadapt. And then what we are going to do is to select it. So click it to select it, and you'll be sent to this page. So when we are here, when you come to this side, single end or paired, select paired end. Like this, paired end. I repeat, paired end. And then after selecting paired end, we also need to indicate some stuffs here. All right. So we will do that very soon. Let's just make sure we have selected a paired end. Yeah. So you should select paired and you should see this coming up. If you maybe you select paired end and you don't see anything, just click again and select it to make sure that you have your paired end specified, and you also have this information here. So if you select paired end, you have an entry to select read 1 and an entry to select read 2. So that's what we are going to do here. All right. So here it says FastQC/A file 1. So file 1 is for read 1. So when you come here, you may see read 2 being selected, but click it and select read 1, the 1. That is what we have to select. I'm going over again, select read 1. Click and select read 1. And then when you come to file number 2, that is for read 2. So that one may be specified, but if you still don't see it, click it and select read 2. So that we have the pairs there. After that, we need to specify some options here. So we are here. At this side, we are skipping it because we did not create the paired end collection. So I'll come to filter options. It says minimum length R1, that is 20. So that's what we are going to select. So let's get back and go to filter options. So scroll down. Not this side, this one you can click to just hide it. You don't need it. Come to filter options here, this one here, click it. And then when you come to minimum R1, select 20. It's 20. Let's just confirm. Yeah, it's 20. All right. And then the read modification options, quality cutoff is 20. So that one is supposed to be somewhere here. Let's hide this first because we are done with it. Let's come to read modification, cutoff quality is 20. So that's it. So we have them done. Okay. So there's also an explanation here, a bit of explanation. So it says trim low quality basis from prime end or 3 prime ends of each read before adapter remover. So apply to both. Yeah, so there's a description of the quality cutoff. So we are using 20. And for filtering of length, we are using 20 as well. So I think that is all for the options. What else? Okay, it says output selector. So we select report, Cutadapt, pair adapter statistics. You can use this with this. So we also select that. So just hide the read modifications options and come to the select this one here, output selector. So we select this one here. All right, so click it and then it will be selected for you. So once you are done with that, you can click on run to run it. So this will run Cutadapt and we are going to have your outputs displayed for you. So let's wait for Cutadapt to complete its work. Okay, Cutadapt has completed its work. So we will have 3 outputs. They are here. One output is for read 1, another one is for read 2, and there is another one which is a report. Okay, so an output for read 1, an output for read 2, and there is a report. Now let's go back to the Galaxy tutorial page to look at the discussion that has been given there. So there's a question that says, why do we run a trimming tool once on a paired end dataset and not twice, one for each dataset? So we have the answer here. Okay, now with what has been given here, I will just put it in my own words. I will just rephrase it just so that we are clear. So if you're dealing with a paired end dataset, for example, in our case, we have this. Let's just check. We have this and this. All right, they belong to the same sample. And so if we supply those files to the trimming tool, whatever processing that is done for read 1, that's the forward, the same processing should be done for the reverse, that is read 2 in our case. All right, now linking that to, let's say, filtering, or let's say even trimming. Let's just say we want to filter, we want to remove some reads. If let's say we have, let's say, read A for the forward data or the forward file. Okay, if let's say that read, all right, that read is, let's say, the length is, let's say, 19 BP, and then we've set our trimming tool, okay, to filter out reads that are shorter than 20. That means that the read A for forward will be filtered out. But because we are dealing with paired end reads, its mate pair, which is in the reverse, should also be removed. Okay, we should have the same treatment for both. But it's possible to save that information to a different file, but because we are removing one, then the mate pair should also be removed. So the same treatment should be given for both forward and the reverse. Okay, so that's why we have to run the trimming tool once on the paired end data set and not twice. That is one for each file or one for each data set. That's basically what I will say here. All right, so we have some information here that tells us of what we also have to, or what we also need to know about the trimming. So it says for the trimming tool can remove sequences if they become too short during trimming process. For paired end files, it removes entire sequence pairs. That's what I was saying. If one or both of the two will become shorter than the set length cutoff. Remember, I talked to you about the treatment. So the same treatment should be given for both forward and the reverse, because we are dealing with paired end data sets. So both files belong to the same sample. Okay. Reads of a read pair that are longer than a given threshold, but for which the partner read, that is made pair. In some tutorials, you will see made pairs is the same thing. Okay, which the partner read has become too short can optionally be written to a single length files. I mean, for tools like Shomu, it's possible to do that. So that information with there, but for the most part, what we want is the same information should be in the reverse and then the forward. We should have the same information there basically, because we are dealing with paired end data, and then that's how it's supposed to be, so that we can have a good output. Let me just put it that way. So that's why we have to run the trimming tool once on the paired end data set. All right, now let's proceed. So let's do this. Let's look at the next activity. The next activity is to run multiqc. Okay, so we run multiqc on the output. Now with our data is a single sample, so you can just take a look at the reports, but I would like us to still run the multiqc to get a feel of it. Okay, that is learning how to use multiqc on Cutadapt reports. But if you had multiple samples, so then all the more reason why you have to use multiqc, so that all the reports will be aggregated for you. But let's run it to see the multiqc output. So let's get back to our platform, and then let's run multiqc on the Cutadapt output, I mean the report. So we will search for multiqc, and then we'll open it, and then when we come here, which tool was used to generate the logs, we will select Cutadapt. So search for it, and then select it, Cutadapt/streamgalore, and then select the reports, which is this one here. Okay, and after that, what we do else, let's check. I think that's it. So we will just run the multiqc tool. So let's click run tool to run it. All right, multiqc has completed its work. So we have the web page report here, which we can view. So I'll just download it. But before I download, let's take a look at the Galaxy tutorial page here to see what we have. So we have some questions here, and the answers are here. So we will just use our outputs to just compare what is here to our reports, the one we have generated. So we will come back to the questions here later. So let's download the multiqc report. So I'll click and I'll download. Now you know the drill. So just download and let's go. So here I'll say Cutadapt. Yeah, so it's just to differentiate this from what it's here. So there's a Cutadapt multiqc. Yeah, so I'll now take a look at the HTML file. All right, so this is it. So I'll just open it and unzip it, or let's say extract it. Now I'm just extracting, by the way. So the file is supposed to be here. You should take note of the number. So that one is this one here. It's this one. All right. So even when you open it, or even when you take a look at it, it says on data 14. So you can use that to check the file here. If you have many files, then you can use the numbers to differentiate. So this is our report. So let's open it. Nice. So now we have the report here. All right. Now let's also look at this stuff here. It says how many sequence pairs have been removed because at least one read was shorter than the length cutoff. And the answer is 1.4% for this sample. That's what we are using. Okay, so 1478110. All right, that's what we have here. So we can get that info here. Let's just check. So when you hover your mouse, you can see it here. So we have pairs, passing filters, pairs that were too short. So we have 1478110. That's 1.4%. Okay, that is what is being stated here for us. So we see that here. So it's telling us, the statistics, for the filtering. So, that's how it is. There are other things you can do. We also have percentages that you can also check. But now it's just one sample, so it's easy to just look at what is here. But I'll skip this detail. I'll skip this because the focus is more on the mapping section. But this is just to let you know you have a report like this. So you can actually use this report to get a better understanding of the data and then the trimming or filtering process. So that's what I thought I will let you know. Now on the tutorial page, it also says how many base pairs have been removed from the forward reads because of bad quality and from the reverse reads. All right, so for that one, the answer is here. Let's check it here. So it says the multiqc output only provides a proportion of BP trimmed in total, not for each read. So if you want the information for each read, then you have to use the original Cutadapt report, and that can be found here. So this is the original Cutadapt reports, which is here. So we can download and examine it also. So let's click and then download it. So I'll just say Cutadapt reports, and then I'll go and open that. So I'll just click it, and it says here. It's a text file, by the way, so you can open it with your text editor. So let's open it. Okay, so this is the Cutadapt report. So we'll use that to answer the question that has been indicated here. The question 2, let's see. This one here. The answers have been given here. So for sample 1, we have this number of BP being trimmed. That's for read 1, and then this for read 2. So we can take a look at that here. So that's quality trim. That's this section here. So read 1, this is the total, and then read 2, this is it. Okay, so that is what has been indicated here. All right, so that's it. So all right, so now we can proceed. So let's continue. We will now move on to the mapping side because that is the main activity. But we have to do this quality control because that is also equally important. So with the mapping, we are going to use RNA STAR to do this. And by the way, I've covered the command line version of RNA STAR. That's STAR, by the way, we call it STAR, but for the Galaxy platform, they'll say RNA STAR. All right. All right. So we are going to perform the mapping using STAR. And by the way, I have covered the command line version of this tutorial as well. So if you're interested, you can check the description box. The link to that video is there. So with STAR, you also need a reference sequence as well. And then we also need the GTF also. So we are going to do that now. Okay, so let's just scroll down. And by the way, I also encourage you to read the notes here to get a better understanding of the mapping process, and then you can proceed. So let's scroll down to the activity itself, which is here. So we'll do that now. So with STAR, we will need the reference sequence. So for the command line, we will need the FastQC, we will need the GTF, but the Galaxy platform already has the index reference. That's for the FastQC, so we wouldn't need it. But we will import this file, the GTF, and then use that. All right, so that is what we are going to do next. So let's get back to our Galaxy platform, and then let's do this. All right. So let's get back here. So what we are going to do first is to import this file, this GTF. So I'll just do it here. So I'll copy the link, and then I'll move to my Galaxy platform, and then I'll click on upload data, and I'll click on paste/fetch data. So I'll just paste it here, and then I'll click on stats. So this will import it for me. Okay, the file has been imported. Now let's get back to the Galaxy tutorial page. So after importing, there are two things we have to do. Number one, rename the dataset if necessary. And number two, verify that the data type is GTF and not GFF, and that the database is DM6. We are going to rename, but let's first verify that the data type is GTF and that the database is DM6. So let's get back to the platform. So when you are here, click the file and then check this side. So format is GTF, but database is question mark. So this is where we have to resolve. So we will rename and then also make sure that the database is DM6 as has been indicated here. So let's do both. So first of all, click the file and then come to the pencil icon here. All right, so click it to edit the attributes. So when you click it, you have this coming up, and then we are going to rename the file. So I'll do it here. So I'll just remove the extension, the .gz, so that we have the file ending with .gtf. And then when we come to database build here, click it and then search for DM6. So when you search for DM6, you may see two items coming up. Select the first one. That's what I did, by the way. So select the first one and then click save. So when you save it, you can check the right side and you see that format is GTF, database is DM6. All right, so this is how we change the database so that we have DM6. So now we have also formatted the file or the data properly, so we can proceed. So let's just exit the attributes section and then let's proceed. All right, so you can still check again to check. So GTF DM6, so everything is fine. So let's continue. Okay, so let's take a look at what we are going to do next. So let's go back to the Galaxy page. Okay, we are here. So we have imported our GTF. So we are now going to perform the mapping with STAR. So we are going to do the mapping, and we are also going to get the mapping statistics. All right, so we will start with STAR. So let's get back to the Galaxy platform here, and then let's search for RNA STAR. The tool is STAR, but on the Galaxy platform, it's labeled as RNA STAR. Take note of that. So let's check it out. So, or you can type STAR also, and you can type RNA STAR, but I'll use STAR. So when you come here, you'll find a couple of tools with the name RNA STAR, but we are going to use this one here. RNA STAR gapped read mapper for RNA seq data. So this is what we are going to use. So click it, and then you will be given the tool. So here we will select our data, and then we are also going to select some options. So first of all, single end or paired end reads. We are using paired end. So we have our paired end as individual data sets. So this is what we are going to use. All right, so we click it. And then when you come here, we are supposed to select forward reads and then the reverse reads. So the forward reads, let's check them from here. We are using the Cutadapt output. So forward read is this one here. Cutadapt on data 2 and data 1 read 1 output. So that's what we have to select here. That's for forward. So click and then select. So it's read 1 output, this one here. And then the reverse reads, that is here. That is this one here. Cutadapt on data 2 and data 1 read 2 outputs. So if you don't see this, make sure to click and select it. So these are the reads. Now, what else do we have to select? So here, we've done that. That's for the reads. Custom or built-in reference, we are using an inbuilt index. So we will leave this as it is. And then when we come here, let's just check the information here. So when we come here, it says use genome reference without built-in gene model, but provide a GTF. So that's one we have to check from here. So it says use genome reference without built-in gene model, but provide a GTF. So this is the option we are going to use. Again, if you don't see this, click and select it. All right, so click and then select it. So you should see it here. And then when you come to select reference genome, you have to click and then search for DM6. So when you search for DM6, you will see its appearance. So click it to select. So this is what you should see for the reference genome. And then when you come here, gene model GTF3.GTF file, blah, blah, blah. We are supposed to use the GTF file that we imported. The one we imported, renamed, and then change the database. All right, so that is what has been given here. So we have that here. That is it. Now, what else do we need to select? Let's check the Galaxy tutorial page. So it says length of the genomic sequence around annotated junctions, 36. So when you come to the platform, you have to search. So this is it. So 36, like this. All right, that's it. And then you come back. And then what else? It says per gen/transcript output. So we are going to use per gen read count into bracket gen count. So come here and then scroll down and search for it. So per gen/transcript output. Let's just confirm that here. Yeah. So here we click and select per gen read count into bracket gen count. So this one is what we are going to select. And then what else do we need to do? Let's check. So it says compute coverage. It says yes in bed graph format. So we have to also select that. So that one, you have to scroll down a bit to see it. So scroll down to see it. It should be somewhere here. So just scroll down, skip all this, skip, and then come to this side here. Compute coverage. So click and select yes in bed graph format. So we have that also done. What else do we have to do? Let's check again. All right, so I think that is it. That's all that we need to select from here. So what we are going to do is to run STAR and then perform the mapping. So let's click run 2. All right, so we are done. So let's wait for STAR to complete its work. Okay, STAR has completed its work. So let's take a look at what we are supposed to do next. So let's get back to the Galaxy tutorial page. So what we are supposed to do next is to aggregate the STAR logs. So we will do that here. Of course, for this tutorial, we are using a single sample. So what we will get is for a single sample. So once we do that, we will also look at the questions and then the answers here. So let's get back to the Galaxy platform and then let's call multiqc. So let's search for multiqc. So it's here. So I'll click it. And then when we come here, which tool was used to generate the logs? I click it and then I search for STAR. And then I'll select it. Then I will insert the output. So I'll click it and then I'll select the output. So the output of STAR is what we are supposed to use. All right, so let's just check here. So we have the log. So RNA STAR on collection log. So let's search for it here. So we should see That's file somewhere here. Let's check it. So this is the file. All right, this is the file. You can also search for it here. When you are here, just check the one with log in it. That's number 21. So that is what I have selected here. So that's the star log. So I'll select it. I've done it, by the way. And I think that's the only thing we need to select, and then we can run the tool. So let's run multiqc here. So I'll click it to run it. So let's wait for multiqc to complete its work. Okay, multiqc has completed its work. So we are going to download the web page and then view the report. So I'll click it and download. So I'll download. So here I'll say star underscore multiqc. I'll save it and then I'll open it. So I have that somewhere here. This is it. So I'll extract the HTML file. So let's take note of the name. So it's multiqc on data 21 webpage. So that's what I'm going to use. So where is it? Yeah, this is it. So I'll open it and then check the reports, the mapping statistics. So we will use this to answer the questions. Of course, the solutions are here, but we'll just compare with what we have. Yeah, so we should have something similar. So number one says, what percentage of reads are mapped exactly once for both samples? So here it says more than 83% for this sample. Of course, this is what we are dealing with. We didn't use this one, so we will not be able to answer, but we have this. It's more than 83%. So let's take a look at it here. So when you are here, just hover your mouse and you see some statistics here. And we also have this color scheme here to help you know what each of these colors represents. So here, this color represents uniquely mapped. Uniquely mapped, that's mapping once. That's what it means here. All right. So when you hover, you see that uniquely mapped is 83.1%. That is what is being referred to here. Reads that map exactly once for both samples. But here we are dealing with one sample. All right. Okay, so we have that it says more than 83% for this one here. All right, so we are dealing with a single sample. So reads that map exactly for this sample is more than 83%, and we have that here, uniquely mapped. We also have others here. And then let's see, it says, yeah. Okay, so there's also this statement here which tells us that we can proceed with the analysis because we have quite majority of the reads mapping uniquely. And so if, let's say, we had a percentage below 70, then this would have called for further investigation. But because we have a percentage of more than 70, things are looking good. So ideally, we should have majority of the reads, or let me just say a high proportion of the reads mapping to our reference sequence. And that's what we see here. Okay, so we also have other statistics. It says, what are the other available statistics? All right, so those ones are here. That's what we see here, the other colors. So when you hover your mouse, you see the other statistics as well. So you can check them out to see what is happening. Okay, so that's what we have at the moment. And so we also have this statement. It says we could have been probably more strict in the minimal read length to avoid these unmapped reads because of length. And so with STAR, if you're on it, you can specify some information that STAR will use to perform the mapping and the analysis. And so we can be stringent with it, but for this tutorial, we just use a standard options, but it's possible to change them. And so you will have to look at the STAR manual, check the available options, and use the ones that you see fit, or the ones that you think will be appropriate for your work. So those ones I will not cover here. You have to check and find out yourself. So that is it. Okay, so I think that is it for the report. So after mapping, you need to check the reports, the mapping statistics, and then from there you decide if the data is worth using for a downstream analysis or further processing has to be done. So that one you have to decide after getting the statistics. So that is it for the mapping. Yeah, it's here. That is it for the mapping. So You can also download the BAM file if you want. That's also up to you, but I will leave it here because I'm just working on the Galaxy platform. Now with RNA Seq, after performing the mapping, one of the things you can do is to also get the read counts. All right, so you can use tools like featurecount to do that, and I've covered a tutorial on that. And even before you also use featurecount, for example, you need to determine the strandedness. So that is something that I'm going to cover in another tutorial, but you still have that tutorial here, by the way. I think it's somewhere here. Estimating the strand, that's something you also have to do. And even before you even estimate the strandedness, you can also inspect the mapped reads. You can inspect the BAM file. So the BAM file contains alignment records. So you can inspect with tools like IGV, and I've also covered a tutorial on that, by the way. And so you have to decide if you want to inspect or not. But it's always important to do all these checks just to be sure that you have a good data, or let me say you have high quality data that you can use for the downstream analysis. So just check the description box. The tutorial for IGV is also there, and you can learn more. So I try to cover both the command line version of the tools as well as the ones on Galaxy, so that beginners will have a bit of both worlds. So that is how we do it. All right, so that is it. So after inspecting your mapping results, after getting your strandedness, you can generate your read counts, and you can also perform the differential expression analysis with tools like deseq. I've covered the deseq tutorial as well. And so if you're interested, just check the description box. There's a tutorial for Galaxy. There's a tutorial where I use the command line version, that's the R, to also do that. So just check the description box. You'll find all tools that you need about RNA Seq analysis, and I'll be making more content on that. So just come back to this channel and then watch more. Again, you can also check this playlist here, which has more tutorials on RNA Seq analysis.